Hey there and welcome. Have you ever really stopped to think about what happens in that tiny fraction of a second after you type a website and hit enter? It feels like magic, right? Well, today we are going to pull back the curtain on the internet's secret filing system, DNS records.
No, really, think about it for a second. You type, you hit enter, and bam, the site is just there. It's not magic, but it's an incredibly elegant system working at lightning speed. And in this explainer, we're going to break down exactly how it works. All right, so here's our roadmap. We'll kick things off with the big picture, DNS as a massive digital directory. Then we're going to meet the key players, the master file, the address records, and the mail carriers. We'll also see how DNS keeps up with the constantly changing internet, and to wrap it all up, I'll show you how to become a DNS detective yourself.
So at its core, the domain name system, or DNS, is really just a giant worldwide address book. I mean, can you imagine having to memorize long strings of numbers for every single website you visit? No way. We use easy names like example.com, and DNS does all the heavy lifting of translating those names into the right IP addresses. And every single entry in this giant address book is called a resource record, or RR for short. This is the fundamental building block of the whole system. Just think of it like one contact in your phone. You've got a name, and it's linked to a piece of information, whether that's a phone number or, in this case, an IP address. Now, there are a bunch of different types of records, but we're going to focus on the real heavy hitters, the ones that make the internet actually work. We've got the SOA record, which is like the official rule book, the A record, that's the actual street address, PTR for doing a reverse lookup, CNAME, which is just a nickname, and finally, the MX record, the postal address for all your email. First up is the Start of Authority, or SOA record. The best way to think about this one is as the title page for a domain section in that big address book. Every single domain zone has to have one, and it's always the very first record. It basically says, okay, here are the ground rules for this domain and who's in charge. Yeah, so this SOA record is pretty much the administrative heart of the domain. It lists the main server, the admin's email, and you'll notice it uses a dot instead of an @ sign, which is just a little historical quirk. But the absolute most important field here is the serial number. Think of it like a version number for the file. Every time an admin changes anything, they have to increase this number. That's the signal to all the other DNS servers out there that, hey, there's an update, grab the new info. The rest of these fields just control the timing of that whole update process. All right, next up are the two record types that you are using constantly, every single day, without even realizing it, the A and PTR records. These are the absolute workhorses of the internet, doing the most basic, most vital job of all, finding stuff. And this shows their relationship perfectly. They are literally two sides of the same coin. An A record, A for address, answers the question your browser asks millions of times a day. Hey, what's the numerical IP address for this website? Simple. The PTR record, or pointer, does the exact opposite. It's used by other servers to ask, okay, I've got this IP address. Who does it belong to? And that reverse lookup is super important for stuff like verifying email servers and network troubleshooting. Okay, so we can go from a name to a number, and from a number back to a name. That's great. But what about some of the more specialized jobs, like creating a shortcut for a server or making sure email ends up in the right inbox? Well, that's where CNAME and MX records come in. So let's walk through how a CNAME, or Canonical Name record, works. It's basically just a nickname. So let's say your browser starts by asking the DNS server, hey, what's the IP address for blog.example.com? But instead of getting an IP address back, the server says, whoa, hold on. Blog is just an alias. The real canonical name is server1.example.com. Go ask about that one instead. And this is incredibly useful because it means you can have tons of different nicknames all pointing to one machine. And if that machine's IP address ever changes, you only have to update one A record, the one for the real name, and all those nicknames just automatically follow along. And then we have the MX, or Mail Exchange record. Its one and only job is to tell other servers where to send email. But the really clever part is this priority system. See those numbers? Mail servers are programmed to always try delivering to the server with the lowest number first. So it'll try the server with priority 10. If that one's down for some reason, no problem. It just moves on to the next one in the list, priority 20. It's a simple but really powerful way to build in a backup for your email. Now, up to this point, we've kind of been talking about DNS as if IP addresses are set in stone. But in the real world, especially on modern networks, IPs can change all the time. This created a huge problem,
And it led to a really smart solution: Dynamic DNS. So here's the problem. What happens when a device on your network gets its IP address from a service like DHCP, which just hands out available addresses automatically? Well, the moment that address changes, the A record we have in our DNS address book is now pointing to the wrong place, and nobody can connect.
And this really shows you the difference. The old way with static DNS meant that every time an IP changed, some poor network admin had to go in and manually update the A record. As you can guess, this was slow, it was a pain, and it was super prone to human error, which meant downtime. Dynamic DNS, or DDNS, automates this whole thing. Now, when the DHCP server hands out a new IP, it automatically tells the DNS server, hey, update your records. Everything stays perfectly in sync, no humans required.
So now you've got the theory down. You understand how the internet's most critical directory actually works, but, the best way to really learn this stuff is to get your hands dirty. You can actually look up these records for any website you want right from your own computer. It's time to be your own DNS detective.
All you have to do is open up your command prompt or terminal. If you're on Windows or Linux, you can use the command nslookup. If you're on Linux and want a bit more detail, the dig command is fantastic. Just type the command, a space, and then whatever domain name you're curious about and press enter. You'll see it all: the A records, the MX records, everything we've been talking about. So at the end of the day, that's what DNS really is. It's the invisible, absolutely essential map that our entire digital world is built on. And now, you know how to read it. So the only question left is, what does the map for your favorite site look like? Go on, go find out.